This computer has many, many switches. And we assume that this switch is correctly on and off as we desire, but that's not true. So there is a round-off error. And another source of error is because of the form I approximate. So that we call the form error. And the other one we call round-off error. Okay? And this Euler formula is not very precise form. So there is a famous method that is widely used in numerical calculation. How do you pronounce this? Longitudinal. How do you pronounce this? What about you guys? You don't know. Some people pronounce it longitudinal, longitudinal, so on. But if you was taught by the people who learned in the United States, they even call it longitudinal. If you are somebody who is influenced in German pronunciation, we would call it longitudinal. Doesn't matter. Okay? That's the one method of numerical integration method. Okay, that's it. There are a lot of different methods. Okay, but that's not the main subject of this course. So I'm just introducing that there is a method to do numerically. So, analytic method, Laplace transform, and the direct integration. There's three ways to get the response of this linear differential equation. Okay? That's what you have to write down at the end of this course. And that's what I want you to understand. Okay, how about this one? What I can do is, I will let x1t is equal to xt. And then I say x2t is rate of change of x1 dot t. Okay? Then, what I can write is x1 dot t is equal to x2t. And then I said x2 dot t is x1 double dot t, that is x double dot t. Therefore, using this equation, I can write x2 dot t is minus c over m x1, right? X2 t minus k over m x1 t. Okay? Then I can write this in matrix form. x1, x2 dot dot is equal to some matrix, and there is x1, x2. Okay. Then this will be 0, 1, and minus k over m minus c over m. And this is x dot equal a x time equation, and this is the same as what we handled over here. Therefore, we can use the same Euler's formula to get the solution of second order differential equation. If you already took the control theory, this kind of approach, we call it what? State-space equation. Okay? State-space equation is a sort of transformation. I want to see the problem in state space because it is convenient. In the beginning, it is not convenient. But if you understand very well state space, then it is convenient to understand vibration system. Okay. Now, this is the end of chapter 1. And let's move on to chapter 2, which is more exciting. How many students actually saw the lecture video? Please raise your hand if you saw the lecture video. Nobody? Wow. And you don't need to have a lecture video? It's useless? Huh? You don't want it? I want it. Later on? Later on when you study midterm examination. But it's interesting, the number of hits of the lecture video is a lot. Maybe some other people in the United States, maybe people in India, they're going to copy them. So how many students do think that the lecture video is not necessary for this course? Lecture video is not necessary. Because your lecture is so clear, and we don't want to, there's no need to see the lecture again. And maybe some students said, your lecture is so terrible, and your lecture does not really help us to understand the course. Just to read the book and do the home, that's the only way to learn vibration. We are just sitting here together at some point because you said if you are absent in the course, you would consider the presenting the absentee in the course. It's very silent. Do you think that videotaping of lecture has to be go on? Yes? Because you are not doing videotaping, you can say yes, but those guys who's taping the video